All right, on part one of our introduction to statistics, we talked about the median and the mode, and we referred to learned about modes being individual, or we could have a bimodal or a multimodal type of mode in terms of our central tendency. Now we're going to kind of move on here and talk about the median. So far we've covered the mean, the mode, and now we're going to be discussing the actual median. So again, median is another one of the three measures of central tendency. And this is the value that's going to occur right exactly in the middle of your data set. So we use the symbol X and it's pronounced as the X tilde. So again, we've got the X tilde symbol over the italic X. And that is the symbol that we are using to represent our median. So you need to recognize that particular symbol here as well. So now, the median, again, is the value that occurs right exactly in the smack dab center of the data set, and once we have arranged it in numerical order. So if we take a look here now, here's our data set. We've got data from all over coming in, and it's ranged in all sorts of odd ways. So the first thing that we need to do when we go to determine what the median is on a data set is to kind of rearrange it into order from lowest to highest. So here we've got this taken care of. Now let's also take a look and count the number of values here. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values here as far as our data set. And we can sit there and say, all right, since I've got 11, an odd number, the one that is in exactly the middle of it is our median. We'd say the median equals 21, or X tilde is 21 in this particular data set. So we can circle that. Now let's kind of go in here and take a look. Now we've got a little bit more data. So we've got an even number of data in our data set. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We don't have an odd number, so we're not going to have one exactly in the middle. So in this case, we are going to have to take, since we know that the exact middle of the data set is right here between 21 and 23, we're going to have to sit there and average those two together. So we can sit there and say, all right, the median here is 21 plus 23 divided by 22, and the median in this case of this data set is 22. Then we talk about range. So we're going to talk just a second here. You guys are familiar with this type of data variation. So especially if you've done any type of machining or making parts within tolerances and confirming that parts are making the tolerances, this is what we call. It's the range from the smallest value to the lowest value, or to the largest value in a data set. So the symbol here is R, so R for range. So here's our data set again. So now we're starting out with the low number of 3. Our high number is 44. So we take, in order to determine the range, we take our maximum value minus and subtract our minimum value. And if we're taking 44 minus 3, here the range of this value set is 41. So next, and this is a short video, I'll kind of go into the heart of standard deviation, or in manufacturing terms, we call this Six Sigma, our standard deviation in terms of Six Sigma variation. So again, as we talk about standard deviation, it's a measure of the spread of the data values. And math gets a little bit more complicated, but you guys are all capable of doing this. Understand that when we're doing this on a manufacturing side, or in a quality control lab type setting, we're familiar, we're using computers and computer technology. We're letting the computers kind of crunch these numbers as we go through. But you need to still understand how the numbers are being derived and what kind of brings those in. So a larger standard deviation so is going to indicate a wider spread of data values. So a couple of things that you need to know about standard deviation. The larger the standard deviation means we have a wider spread of data values. So here's a formula for standard deviation. So again, this is the Greek letter sigma, i.e. the reasons for the term Six Sigma. So sigma stands for standard deviation, and we say that equals the square root. Remember this epsilon sign here for the Greek letter epsilon means the sum of. Here is our standard values in terms of our data values minus the mean. We square root that, and then we divide that by n, which is the size of the population of our data set. So that is what the formula for standard deviation is. So now here is our step-by-step procedure, so that you're going to need to kind of be aware of how to do this. So first we calculate the mean. So we subtract the mean from each value and then square the difference. Then we sum all of the square differences. We divide the summation by the size of the population, i.e. the number of data values, or n, and then we calculate the square root of the result. So, all right, let's kind of refer back here one more time to the note about rounding and statistics. So in general, we're not going to do any rounding at all until we come up with the final answer. So, all right, if you're writing immediate results, you can kind of round values, but keep unrounded number in your memory as you go. So we are always going to round to one more decimal place than the original data. So if we have a two-place decimal on the right side of the decimal point, we're going to round to the third decimal place to the right side of the decimal place. If we have a four-place decimal to the right side of the decimal place, then we're going to round to the fifth decimal place to the right side of the decimal. So if you need to stop and listen to what I just said again, pause, stop the video, rewind, and listen to that again so that you understand the concept here. We are always going to round to one more decimal place than is in the original data set. So I'm going to stop the video here. So you're seeing a standard deviation calculation here. But I'm going to stop the video here, let you kind of absorb this information, go back over, make sure that you understand this, and then we'll come back for the third part of this video series, and we'll actually run through the standard deviation calculation.